Thanks for joining in. We're going to be talking about future of observability with self-healing systems. I know this sounds kind of catchy, but this is like very simple and how you can make it work with your ecosystem with the tools that we have right now. I'm Ghyan Shah. I work building AI systems with legal research for Thomson Reuters. And with the modern tooling that we have right now at our disposal, we're going to be looking at how we can connect everything and kind of see how we can take this to another level. A quick show of hands, who here has been paged in the middle of night for an issue? Um, or maybe you have to look at it very late in the night and work for a couple of hours until you get some time to sleep. Yeah, a couple of us in the room, right? And this is very annoying. You diagnose the issue for a couple of hours, let's say 4 or 5 hours, and then kind of get to know that it was really simple and it was embarrassing to even talk about it. And all the while, the root cause was something embarrassingly simple. And I think that's the paradox of modern observability. We have more data than ever. We ingest terabytes worth of logs, track every metric imaginable, and yet we are playing detective at a very worst possible time. With incredible opportunities that we have with large language models, MCP, software agents, agentic infrastructures, we have like a wide variety of tools that we can use. And with the freedom that we have to completely reimagine how we approach this process, the models are evolving rapidly. And that is a great space where we can use this. In the next 10 minutes, I'm going to talk about what is the traditional observability cycle, how we can connect everything within our ecosystem, how we can go from detection to remediating a fix, how the entire paradigm of human in the loop with, let's say, modern AI tooling has been redefined, and how you can build your own self-healing system within your enterprise. Now, traditional observability is kind of a maze of interconnected services. When something breaks, you cannot find root cause within a single microservice or a single system. You have to go through all different layers of, let's say, Kibana or code bases, documents, and stuff like that. It could be like a database connection pool, a race condition between microservices, or a dependency that you might not even see it or might not be in the jurisdiction of your team. Let's take a scenario, for example. I get a customer ping that checkout is sometimes slow. And then there's two ways that we'll take a look at how we approach this. One is the reactive approach, and the another one is proactive approach. Reactive approach is you get paged, you start looking into the issue. Let's say at 10 a.m. in the morning, the hunt begins. I look at the logs in Kibana. I see timeouts, but they're not interconnected, so I cannot point it down to one single issue. The metrics are green. The CPU usage seems fine. Memory usage seems fine. All the metrics on my dashboard look green. So it's like I don't have a pen. It's a dead end for me. I check the deployments. Over the last week, there have been like 12 deployments, which have a numerous number of PRs raised and merged. So it's kind of difficult for one person or a couple of people to look into all of those PRs that have been merged. And a couple of engineers get involved. I get lost in the maze. Cannot reproduce it consistently within staging. I add logs to prod, see how it's happening. Someone in the team chat pops up and says, "Oh, it worked last week. I don't know what happened," and no one is ready to take the blame. And finally, after a lot of debugging sessions, someone finds that it was an issue in the session service within a PR that got merged last week, where if you have multiple tabs open, it does not refresh the session, and it's kind of a deduplication issue. How we can tackle this with a proactive approach is we use Elastic AI to find anomalies. It will trace through all the logs and it will come up with, let's say, that auth call rate was spiking up by 300 times over the period of last 6 hours, which is like a high risk anomaly. Agent monitors across all of my 18 microservices to see what take the issue trace and then see across that if it's related to any of the code base. We try to find a pattern and we see that auth service was called 3 times per checkout. Then we have automated distributed tracing and remediation where we map the full path. We see the time being and the latency for every service, every checkout. see that session is taking 550 milliseconds. The agent identifies bottleneck, it does code analysis, it finds the culprit PR, and it traces it from, like, say, 3 days ago. We find the impacted customers. Then the agent does code inspection, and it's like a very simple change. So agent remediates a fix. Engineer is notified on Teams or Slack that this was the issue. We have remediated fixed. You should take a look and merge the PR. The engineer takes a PR, it looks good, tests it, and then it's all CI/CD from there on. And how this works underneath is how we connect all of these different services that we have across all of our ecosystem. Uh, we have for detection and memory, we have Elastic, where we primarily use it as a source of truth for logs. We do log classification based on top of it, store it in the memory, and if any anomaly is detected, it goes to the orchestrator agent. What orchestrator agent does, it will go across all the different services that we have. Let's say I have observability, I have code bases, I have infra, I have data, I have ops. It will go run parallel investigation across all of these different services and then try to correlate a change across all of it. Findings from all of this investigation come to the correlator agent, where we try to find and map the issue and create the entire trace. And after then, it goes to the remediation agent, where it adds a fix using coding agents, and then we involve human in the loop to review it, because of course we cannot merge it right away. I could lose my job, and then deploy it. And basically, how you can build this and go from detecting the issues to remediating the entire fix is basically 6 simple steps. Uh, One is pattern recognition. We have a huge amount of logs, but to make context out of it and have rich context that we can serve to the agents is very difficult. And that is where we use the Elastic AI stack to help us get more context-rich information, more information on anomalies, more information on metrics and stuff like that, and then take it across all of the different services that you might have in your enterprise ecosystem. Map dependencies, automatically trace issues from logs, do error propagation, and then find an RCA. And this is all of this is for active incident, right? But you might have issues, let's say from last 5 years, that you might want to reference as well. And they might be in some other place, maybe ServiceNow, or maybe some other system that you're using. So we want to be able to leverage those as well. So we keep two types of memory. One is short-term memory, and the other one is long-term memory. Short-term memory just keeps context of the active incident that is going on, and long-term memory keeps track of a context or summarized version track of every incident that has happened in the last 10 years. And that helps us look at issues more pragmatically and more realistically when working with actual production scenarios. So you can reference those as well. Let's say more like, imagine a scenario where you're coding, you create a PR, and it could reference from long-term memory some particular issues that happened in last 10 years, and it could give you a suggestion that, oh, because of this particular style of code, this memory spike or memory leak happened, so you should probably take a look at it. And then getting context from all of these different services, you also need a way to correlate that information. Otherwise it is all up in the air and it is of no use. So you connect disparate signals across your entire stack, logs, metrics, code changes, deployments, infrastructure events, messages from your Slack channels, Teams channels, and then prompt it in a way that it correlates the entire information stack more comprehensively. And then there's automated remediation. I think we all use, how many of us use software agents from, let's say, Cursor or Cloud Code or GitHub Copilot? Yeah. So we basically integrate that into the stack, use this information to write code for us, and then involve human only when we need to review it. And proactive prevention is basically avoid incidents from happening in the future with the knowledge that we have right now. With the entire paradigm of evolution with modern AI, some people or a lot of us think, or a lot of us like to comment that this might take jobs away. And I think that is very radical. What happens is humans' role get redefined, and now we look at more complex issues. A good friend of mine told me that now robots are doing surgeries. Does that take doctors out of equations? No. Now doctors perform more complicated surgeries, or do more reviews on, or try to take the robotic surgeries advanced. Humans don't disappear from the equation, they move up to the value chain. Instead of investigating issues, they validate solutions. Instead of writing emergency fixes, they review tested code. Instead of fighting fires, they set engineering strategy and design. There's one good line that I read at, on Twitter the other day. Code is cheap today, show me the design. And you can set, while building the system, you can set progressive autonomy levels. uh, I think a lot of us like to be more enthusiastic about how we build AI solutions and go right away into automating everything, but I think that might lead us into a loop that might not yield good results. So we should set progressive autonomy levels. Level 1 is just investigate. Take your active incident from your last on call, try to set up the system and just investigate. See how you worked and how the agent worked. Did it follow the same thinking path as you did? Did it trace the same error propagation that you did? Did it find the relevant logs? Did it find the right context? Did it generate the right fix? You work only investigation mode and you do like manual comparison of how this is working. And if you gain confidence, you move up to another level, which is recommend solutions. Based on all of this information, you want agents to propose fixes to you. It could be in 3 other code bases or 100 other, and or maybe n number based on how you set this up. And if you think that this is going good, the fixes that are generated are fine, you move on to another, which is let it fix directly. And this is where I find most enterprise would find a more healthy balance between automation and still have human approval and be safe. Agent generates complete solution based on the traces and information that we have. Their humans review and approve before deployment. And this also serves as you should have more software engineering 101 practices here. You set automated rollbacks. You set alerts on if anything fails. You also set a monitoring strategy. And level 4, which I think might be difficult, but if you want to go all futuristic, level 4 is agent investigates, detects, fixes, deploys, monitors for 6 hours, and then pings me. Oh, this was the incident. I fixed it. Maybe you should go to sleep now. Last one is how you can build your own enterprise self-healing systems, which is laid down to simple 4 steps. One is foundation. You get everything right. You don't try to connect every service. You don't try to go all ballistic into how you want to approach this, but do just basic integrations. Connect to GitHub, connect to your source of truth logs, let's say Elastic, and then expose your existing tools for immediate visibility. There's no risk here, but you'll get an idea how this is working. Second is controlled automation. Take incidents from past, see if there are any low risk issues, and try to automate them with approval gates. Progressive rollouts with automated rollbacks as well. And third is scaling beyond POC. This is where, if you've gotten pretty confident about how this system is working in your ecosystem, you scale beyond POC, try to implement this with, let's say, your if you try to implement the level 1 with, let's say, SRE team, where they get immediate benefit from logs and visibility. You build agent specialization, database, API, infrastructure agents working in like a concert all together. You create evaluation and feedback loops as well. And the fourth one and the most critical one, which I think is measuring critical success factors. A lot of the times we build AI tools, but we do not evaluate them if they are actually helpful or if they have a good effort to reward ratio in your teams. You measure MTDR reduction, you measure if the context is getting right, you track the investigation accuracy, you measure false positives as well. One way that we did evaluations at Thomson Reuters was we took incidents from last 1 month and ran them in the same way that a human would. those incidents from past already have good documentation of how they were tackled, what was the RCA, what fixes were deployed. So it acts like a good source of gold analysis, a gold truth analysis versus what the system is doing. And this also tells you more comprehensively about how this works in your ecosystem rather than using some data sets that might not be relevant for your work that you do. And yeah, that is about it. Cheers to a next incident that never happens. Thank you.